Alright, quiz 6, Math 251 solutions. Implicit differentiation. We're asked to find the derivative of this mess. And then it gives me this identity, which really won't help until later on. Maybe I should have written that later on. Anyways, find the derivative of this mess right here. Take the derivative of both sides of this equation. If this equals this, the derivative of x squared y squared plus xy must equal the derivative of x plus y. And what's kind of nice, whenever you have derivatives of sums, you just break them up and find each of the individual derivatives, and your answer is the sum of those things. What I'm saying is we can break this one problem down into 4 different problems. Find the derivative of this guy, derivative of this guy, derivative of this guy, this guy. And then we'll be all done with the calculus part, do a little bit of algebra, and we'll call it good. Okay, the derivative of x squared y squared, probably the hardest of the 4 here. First thing I want you to notice is this is product rule, something times something. The derivative of x squared is 2x. Leave y squared alone. And then add to that the derivative of y squared, which is 2y y prime, and leave x squared alone. Why is this 2y y prime instead of just 2y? Because we're doing the chain rule here. So inside the product rule, I have to apply the chain rule. Because what I have is a composite of 2 functions. The outside function is x squared. The inside function is y. So you take the derivative of the outside part, power rule, gives me 2y. Then you're not done. You have to multiply that by the derivative of the inside part. Anyways, this first thing is equal to this guy right here. And to that, I want to add the derivative of x times y. Really the same idea. Product rule, it's something times something. Derivative of x is just 1. Leave the y alone. Derivative of y is y prime. Leave the x alone. Get this thing. These parentheses aren't necessary. I just wrote them to really emphasize that this turns into this, and this turns into this. On this side, derivative of x is just 1. Derivative of y is y prime. So what I have is 2x y squared plus 2x squared y prime, if I just reorder some stuff, plus y plus x y prime, again just reordering, equals 1 plus y prime. I want to solve for y prime. I have 3 different terms that have y primes in them, so I'm going to get those all together on one side of the equation, meaning I'm going to subtract 2xy squared from both sides and y from both sides and y prime from both sides. When you do all that algebra and the dust settles, you'll get to here. Subtract y from both sides, subtract 2xy squared from both sides, subtract y prime from both sides. What I can now do is factor out a y prime, because each of these 3 terms have a y prime in them. If you factor it out from the first term, you get 2x squared y. Factor it out from the second term, you get x. Factor it out from the third term, you got a negative 1. Kind of low on room, but I'm just one step away. Divide both sides of the equation by 2x squared y plus x minus 1. And what you get for your final answer is 1 minus 2xy squared minus y divided by 2x squared y plus x minus 1. I guess that's it. Next one. A couple options for this guy. Let's see. Option 1 is to just kind of look at this and start taking derivatives. Let's see, the derivative of the left-hand side, gonna have to use some chain rule here. 2 to the xy power. The outside function is 2 to the x. The inside function is x times y. So if I take the derivative of the outside function, it's a lot like e to the xy, except it's 2 to the xy in that you leave it all alone. The only difference is you have to tack on this natural log of 2. But then I'm not done. I still have to multiply that. I should put dy over dx to emphasize that y is a function and x is a variable of xy. So I'm taking the derivative of both sides of the equation. I'm using the chain rule here. And then on this side, I got product rule. So the derivative of 2 to the x is 2 to the x natural log of 2. And then leave the 2 to the y alone. And then add to that the derivative of 2 to the y is 2 to the y natural log of 2 times y prime. That's chain rule. And leave the 2 to the x alone. Get this huge mess right here. And we're almost done. We still have to figure out the derivative of x times y. That's product rule because it's something times something. I get 2xy natural log of 2 times derivative of x is 1. Derivative of y is y prime. And now I just copy everything else down. You have a huge mess here. But we got y primes. We got one y prime here, one y prime here. So if I could get all the y primes next to each other and factor one out, I'd be done. In order to move pieces around, I'd like to get rid of these parentheses. In order to do that, I'm going to take this and distribute it through. So I'm going to get 2xy natural log of 2 times y plus 2xy natural log of 2 times xy prime. And that's equal to 2 to the x natural log of 2 times 2 to the y plus 2 to the y natural log of 2 y prime 2 to the x. What a mess. Get all your y primes together. 2xy natural log of 2xy prime. That's this term. Subtract this from both sides, and I got 2 to the y natural log of 2 y prime times 2 to the x. It's this term right here. That's equal to 2 to the x natural log of 2 times 2 to the y. That's this term here. And then finally I got this term, which I'm going to subtract from both sides of the equation, so it becomes negative 2xy natural log of 2 times y. Both of these terms have a y prime in them. You can factor out that y prime. If I factor it out, I'm left with 2xy. I kind of like my natural log of 2 to be at the end, so I'm going to rewrite this 2xy times x times natural log of 2 minus, and then over here I got a 2y. I got a 2 to the x, 2 to the y, 2 to the x, and then another natural log of 2. And I didn't write y prime because I factored that out in front. And over here I got 2 to the x, 2 to the y, natural log of 2, just rewriting the order, minus 2 to the xy times y, natural log of 2. So finally, pushing symbols around on a page for a while, I could solve for y prime and get y prime equals 2 to the x, 2 to the y, natural log of 2, minus 2 to the xy times y, natural log of 2, divided by 2xy, natural log of 2, minus 2 to the y, 2 to the x, natural log of 2. Since I don't care about simplification, I'm perfectly good with this being your answer right here. Although you might note that we could factor out a natural log of 2 from the top and the bottom and cancel out all of those natural log of 2's. So maybe I'll put a box around this to show that this is perfectly good for your final answer. But as an FYI, factor out a natural log of 2 from the bottom and the top and cancel them, we'd be left with 2 to the x, 2 to the y, minus 2xy times y divided by 2xy minus 2 to the y, 2 to the x. Can we do anything more? I don't know, maybe. Yeah, I don't see anything. Call that good. What I want to show you is there's another way you could do this problem. If 2 to the xy equals 2 to the x, 2 to the y, I could also say that using an exponent rule, 2 to the x times 2 to the y is 2 to the x plus y. And if this equals this, log base 2 of this equals log base 2 of this. Well, I wrote that wrong. Log base 2 of 2 to the xy power is just x times y. Log base 2 of 2 to the x plus y is just x plus y. So now I can take the derivative of both sides, and it'll be quite a bit easier than the derivative I did before. Take the derivative of both sides, solve for y prime, and we're good. So what I was getting at over here is just sometimes you do a little bit of algebra first, you can save yourself a lot of work in calculus. This derivative using the product rule is derivative of x is just 1 times y plus x y prime. Derivative of x is 1, derivative of y is y prime. Get all the y primes together, you get xy prime minus y prime equals 1 minus y. Factor out of y prime, x minus 1. What you get is that y prime is equal to 1 minus y over x minus 1. You might think that this or this looks very different from this, and I agree it does. We can get from one to the other by doing a whole bunch of manipulation by moving pieces around. But they're equal, two different possible answers. This one's a little bit easier calculus-wise. This one's a little bit easier in that we didn't have to do all that algebra beforehand. Okay, arc sine. It tells me that arc sine of x, maybe I'm going to copy that down here, the derivative of arc sine of x is 1 over the square root of 1 minus x squared, I believe. Yep. So what it wants me to do is find y prime. Well, I could just take the derivative of both sides. Y prime equals the derivative of arc sine of x would be 1 divided by the square root of 1 minus x squared. But I don't want the derivative of arc sine of x. I want the derivative of arc sine of x squared plus 4x. So I got chain rule going on. Taking care of the outside function, I get this mess. Leave the inside function alone. But then I'm not done. I have to multiply that by the derivative of x squared plus 4x. So what I get for my final answer is the derivative of x squared plus 4x is 2x plus 4. So 2x plus 4 times all this mess, we could write as something like this. Part D, what if it were this mess? A couple options. Option 1 is to do it like we did above. The derivative of arc sine of x is 1 over the square root of 1 minus x squared. But I don't want the derivative of arc sine of x. I want the derivative of arc sine of this mess. So I'll leave all this mess alone, maybe in a different color to really emphasize that what I'm doing is the chain rule here. Square root of 1 minus cosine squared of 2x. But since I'm using the chain rule, I'm not done. I still have to multiply that by the derivative of the square root of, meaning raise something to the 1/2 power. And what is that something? It's 1 minus cosine squared, which is cosine of something squared. And that something is 2x. So I got more chain rules to do. The derivative of all this mess, well, something to the 1/2 power. Bring that 1/2 down in front. Leave everything else alone. So I got 1 minus cosine of 2x squared. Get all my parentheses right. Those, and I wrote the parentheses wrong. I want to do that one more time. So take this 1/2, bring it down in front here. So we get 1/2 times 1 minus, there we go, cosine of 2x squared to the negative 1/2 power. But then we're not done. We just took care of the 1/2. We still have to take the derivative of 1 minus cosine of 2x squared. And what that derivative is equal to, derivative of 1 is just 1. So the derivative of negative cosine of 2x squared, bring that 2 down in front. Then raise it to the 1 power. And then multiply that by the derivative of, we have one more layer going on in here, 2x. The derivative of 2x is just 2. So what we get for our final answer, maybe I should put in some like these symbols, just showing that I'm too lazy to copy this all down. So my final answer would be 1 over the square root of 1 minus the square root of cosine squared of 2x times 1/2 1 minus cosine of 2x squared to the negative 1/2 times negative 2 cosine of 2x times 2. Something like this. Yeah, you could simplify that if you wanted to, but you don't have to. It's perfectly fine the way it is. Since I said option 1 here, makes it sound like there's an option 2. There is. Option 2, kind of like option 2, somewhere up here. We're going to do a little bit of algebra, or I guess trig in this case, before we take any derivatives. Sine squared plus cosine squared equals 1. Sine squared of theta for any angle theta plus cosine squared of that angle equals 1. So if I subtract cosine squared from both sides, what I get is sine squared of theta equals 1 minus cosine squared of theta. Note that I have 1 minus cosine squared of something here. So I could rewrite that as, so y equals arc sine of something. And what is that something? The square root of something. But instead of writing 1 minus cosine squared of 2x, I could write sine squared of 2x. Why might I want to do that? Well, because now I have the square root of something squared. Those cancel out. Y is just equal to the arc sine of sine of 2x. And why is that good? Because the arc sine of the sine of something is just that something. These are inverse functions. Y is just equal to 2x. So y prime is equal to 2. A lot easier calculus-wise than all this mess here. What that's saying is that if I go through and I simplify this thing super carefully, things should all cancel out. And I don't know, you can kind of see it. This mess raised up to the negative 1/2 power, we'll put it down on the bottom and take the square root. A square root times a square root will cancel out the square roots, and then maybe I can cancel those out with this. Things will all cancel out nicely, and we'll get 2 for our answer. 2 different ways to do that problem. You can do it however you want. This is the more natural way to do things. This is a clever way to do things that makes your life a lot easier. I think that's plenty on this, so I'll end it here.